podcast is a review of factoring as you learned it in Algebra 1 and Algebra 2. The first step in any factoring problem is always to look for a greatest common factor. In this circumstance, our greatest common factor happens to be 3. That is the number that divides into 6, 9, and 12. First, we would write down the GCF, and then we need to find the remaining polynomial. And to find that, we need to divide each term by the GCF. 6x squared divided by 3 is 2x squared, negative 9x divided by 3 is negative 3x, and 12 divided by 3 is positive 4. The second step in any factoring problem is to count the terms so you can determine the method you're going to use. If there are 2 terms, you have 3 possibilities. One is a difference of 2 squares, one is a difference of 2 cubes, and one is a sum of 2 cubes. Difference of 2 squares is the one you are most used to. The factoring pattern for a difference of 2 squares is that a squared minus b squared equals an a plus b times an a minus b. If you think of reversing or think of FOIL, when you multiply the first terms you get the a squared, when you multiply the last terms you get the negative b squared, and think of conjugates. You get the negative ab and the positive ab in the middle, which means the middles will always drop out. So in our first example, to get x squared, we needed x and x. To get the middle to drop out, we need one positive and one negative. And to find the last term, we just take the square root, and the square root of 121 is 11. So our factors were x plus 11 and x minus 11. Similarly, on our next example, to get 36x squared, we would have 6x and 6x, 1 plus, 1 minus, and a y and a y. The next factoring pattern is a difference of 2 cubes. Notice it starts with a difference. It has a subtraction problem. The first factor is a minus b. The second factor actually has 3 parts to it, and the reason it has 3 parts is because of this. If you multiply a times a squared, you do get a cubed. And when you multiply negative b times b squared, you do get a negative b cubed. The problem is you would also have to multiply the a times the b squared and the negative b times the a squared. In order to make those terms fall out of the problem, they needed to add in a positive ab in the middle. Notice when we multiply the outside terms, we had a positive ab squared. When we take the last term of the first times the middle of the second, we get a negative ab squared. When you multiplied the negative b times the a squared, you got a negative a squared b. When you multiply the a times the ab, you get a positive a squared b, making all of those terms go away. On our first example, it is a difference of 2 cubes, so we need to figure out what is cubed to start with. And our first thing cubed, to get 8x cubed, it's 2x to the 3rd power. 27 is 3 to the 3rd power. So we're going to start with 2x minus 3. 2x is in our a position, 3 is in our b position. Now to complete the pattern, we have to square the a factor. 2x quantity squared is 4x squared, plus multiply the 2 pieces together, and 2x times 3 is 6x. And then we have to square the number in the b position, and 3 squared is 9. So our factors were 2x minus 3 times 4x squared plus 6x plus 9. Similarly, with a cubed plus b cubed, we start with an a plus b. Again, the a cubed and the b cubed are going to happen naturally. To make the other middle stuff fall away, we needed a minus ab in the middle. So, on our example, to get x cubed, we had x to the 3rd power. To get 216, it was 6 to the 3rd power. So our a position is x, our b position is 6. So we started with x plus 6. Square the a and you get x squared. Now we need to multiply the 2 pieces together, and x times 6 is a minus 6x now. b, and then square the b position, so plus 36 at the other end. And this is our factoring pattern for a sum of two cubes. If there are three terms, we have two types of polynomials. One is if the lead coefficient is 1, and the best method on this is really to just do guess and check. It's reversing FOIL. We know that the first term in our trinomial came from the first terms in our parentheses, or in our two binomials. So to get x squared, I knew I had to have an x and an x. We know our last term came from the two numbers in the last positions in our binomial. And we know that the middle term came from the outsides plus the insides. So basically what we're doing is we are multiplying for the last term and adding for the middle coefficient. So I'm looking for two numbers that multiply to negative 84 and add to negative 5. If you go through all your possibilities, you'll come up with only one pair which works, which is negative 12 and positive 7. So our factors were x plus 12 and, x minus 12 and x plus 7. We do the same thing on the next one. It's a little bit easier because the signs are all the same. In order to get x squared, we had an x and an x, and then the two numbers that multiplied to 12 and added to 8 are 6 and 2. It doesn't matter which binomial comes first. If it has a lead coefficient, you can still use that technique. It's just harder if the numbers aren't prime. Notice on this first example, the 3x squared and the minus 5 are both prime numbers. That means it's going to be icky, but not quite as icky as it could be. I know to get the 3x squared, there's only one way to get it, 3x and x. And I know to get 5, there's only one way to get that, and that's 1 and 5. The problem is I don't know which one goes in which parentheses. I don't know if the 1 goes with the 3 or the 1 goes with the x. I don't know if the 5 goes with the 3 or the 5 with the x. So what I have to do now is I have to try those out, and I have to check the outsides plus the insides to make sure they add up right. So I just do it, write them in this way, and then I do it with the bottom numbers first. It's a good time to use a pencil. 3x times 1 is 3x. 5 times x is 5x, and because this is a negative here, I know I'm looking for the difference between the two numbers, so 5x minus 3x is 2x. Compare that to the 14x, not even close. If I come up with something that's opposite, I can figure out where my signs belong, but 2x and 14x aren't even close. So I'm going to get rid of the 5 and the 1 in those positions, and I'm going to try it again, only this time I'm going to try it with the 5 in the second position and the 1 in the first position. So as I try that, 3x times 5 is 15x, 1 times x is 1x. Because it was a difference, I need to subtract them. 15x minus 1x is 14x. It's the right pair, but I need to get the sign straight to get a negative 14x in the middle, which means my 15x needs to be negative. In order for 15x to be negative, I already know my 3x is positive, so I need to make my 5 be negative, and then my 1x needs to be positive. So I have my factors right there. Now, another technique that you can also use, it's kind of a combination of master product and guess and check. The master product is what you get when you multiply the first term times the last term. And it just helps you get a clue as to what your factors are going to be. When I multiply 3x squared times negative 15x, or negative 5, I get negative 15x squared. This is my MP, or master product. Now what I'm looking for is two numbers that multiply to that add to that minus 14x in the middle. And the two numbers that would do that are a minus 15x and a positive 1x. Now I'm ready to start figuring out my factors. What I'm going to do is I'm just going to take the first factor and the first one that I just came up with. So I'm going to have the 3x squared minus the 15x. And I'm going to see what they have in common. And what they have in common is 3x. Now, what's left behind is x minus 5. This is important. This is going to be my second binomial. So I'm going to put my x minus 5 over here. Now all I have to do is kind of play the guess and check again. I know I wanted my last terms to multiply to negative 5. I already have a negative 5 here, which meant my other term in my first binomial needed to be a positive 1. So I have 3x plus 1 and x minus 5. Exactly the same thing I got up here, but I didn't have to do quite as much checking on signs and things like that. Now, it's really a lot easier when you come up to a problem like this with 12x squared minus 15, because if I were going to use the guess and check method on this one, I have way too many ways to multiply to get 12x squared. I could do 12x and 1x, 6x and 2x, 3x and 4x. And then to get the 15, 1 and 15, 3 and 5, and then the positives and negatives really mess it up. So this second technique is really a lot easier here. My master product is negative 180x squared. So I'm looking for two numbers that multiply to negative 180x squared that add to a negative 8x. And that would be negative 18x and positive 10x. So I'm going to take the first term and my first factor that I came up with and write it out. That's 12x squared minus 18x. Now let's look at that and see what they share. And what these happen to share is a 6x. So I know one of my factors is going to start with a 6x. I don't know what the other part of it's going to be, but I can get my second binomial. When I factor 6x out of this problem, 6x goes into 12x squared, 2x times. 6x goes into negative 18x, negative 3 times. So it's going to be 2x minus 3 for my second binomial. Now, I have the 3 here. Remember, I'm trying to get a negative 15. Since that's a negative 3, I have to multiply it by a positive 5. And that's my pair of factors. If you have 4 terms, there are 3 ways to group. You can either group it in pairs, which is the first example, or you can group 3 and 1 or 1 and 3. When you group in pairs, what you're looking for is something that each pair has in common. My first pair shares a 3 and leaves me with 2x plus y. Now, when you do it in pairs, that sign in between is really important because it usually means that the second pair has that as a common sign as well. So 8x squared minus 4xy shares a negative 4x, and if you factor out a negative 4x, you get 2x plus y. Now what we look for is the common binomial, which is 2x plus y. If we write that down, and then our other binomial is the remaining factors, which is 3 minus 4x. Our next situation is one where we would group it in 3 and 1. And this is the situation where you're looking for a perfect square trinomial. If you look at the first pair, it is a perfect square. Look at example 3. In example 3, the second 3 is a perfect square trinomial. But because of this minus sign, you have to be really careful. That's like x squared minus the quantity of y squared minus 2y plus 1. Typically, if you have to group this way, what you're looking for is a perfect square trinomial followed by a difference of 2 squares. So here we go with this one very quickly, and I'll leave you example 3 to finish on your own. X squared minus 6xy plus 9y squared is x minus 3y, quantity squared, minus 16. This now is a difference of 2 squares. Here's my first term. So it's x minus 3y plus 4 and x minus 3y minus 4. If we do this one, again, it's a difference of 2 squares. It's x squared minus y minus 1 quantity squared. And you can finish that one out from there. This concludes your review of factoring.